Hello, good morning. Thank you for joining us in this webinar from the project NANOCULTURE that is funded by Interreg Atlantic Area. Today we are going to talk about nanoparticles in aquaculture and to try to give some glimpse about if this is something to worry about. We have the pleasure of having an invited speaker from the Development and Innovation Division of Ireland's Seafood Development Agency, Catherine Butler. Thank you very much for giving us the opportunity of having your presentation today. So we would like to start with Catherine's presentation.
Good morning, everybody. I'm delighted to be here. Very much thank you so much for the invitation. Today, what I want to talk to you about is to give a snapshot view of the business of seafood here in Ireland, and then focus in on aquaculture, because that's the area that I've been working in the last number of years. I work with Bordy Skawara in the Development and Innovation Unit, and today I will talk briefly about two of the projects that we're currently working on. And then to wrap up the presentation, I thought it would be nice to give an introduction to one of the many female entrepreneurs that we have in the aquaculture sector here in Ireland. Now, I'll just get this presentation going. Just waiting for the slides to move forward. Oh, here we go. Great. Okay, so let's start. A snapshot view of the business of seafood in Ireland. There's a lot of information here. But this slide basically is it's a snapshot of the business of seafood in Ireland. All the data here is for 2019. So in 2019, the Irish seafood economy had a value of 1.2 billion euros. That 1.2 billion could be broken down into four distinct areas. Domestic consumption, 496 million. We had government investment of about 177 million, private investment 258 million, and the balance of trade, the difference between exports and imports of seafood, 285 million. If we were to look at the value of actual seafood to the country, it was a grand total, you can't see down here, but of about 596 million. Of that 596 million, 424 million was seafood landed into Irish ports. We have a number of ports around the country. Two of the biggest fishing ports are on the west coast. So Killybegs landed 122 million worth of seafood, and Castletonbear down the southwest landed 130 million. So we had a total of 424 million for the value of seafood landed into Irish ports. In addition, the value of aquaculture was estimated at 172 million. So that gave us our grand total of 596 million. In Ireland, we have approximately over 2,000 registered fishing vessels, 164 seafood processors. In aquaculture, we have 278 licensed aquaculture units. And in total, the seafood industry accounts for over 16,000 people employed around our coast. Now, these are jobs directly and indirectly associated with the seafood industry. And you must remember that these jobs are in most of the time in rural coastal areas of the country. Our domestic sale value has a value of 496 million. That can be split down into 300 million is retail value and 196 million food service value. Our two top exports out of the country are salmon and mackerel. But not only do we export seafood. We do also import seafood. And as we can see, we import about 231 million from the UK. So it's a very important source of our seafood as well into the country. Main markets for our seafood, we have the EU is our main market, followed then by Asia, and in a close third position would be the UK, would be our third market. So because I work in the aquaculture sector, I thought it would be interesting to drill down a little bit into the aquaculture sector. And I'm afraid my screen doesn't seem to want to move on anymore. The gremlins are out today. No, I have. Oh, here we go. Absolutely. Okay, so from the previous screen, we said aquaculture production had a value of 172 million. That actually is made up of 4 main species. So we have salmon, accounts for 110 million. We have Irish rock oysters, or the Gigas oysters, accounts for 44 million. Seabed cultured mussels, they're the bottom mussels, 7 million, and then the rope mussels, 7 million. If you want to break that down in terms of tonnage, salmon, it's about 11,500 tons. The Gigas oysters, about over 10,000 tons. The bottom mussels, 4,500 tons, and the rope mussels, 10,000 tons. So that was just a really quick snapshot of aquaculture and the whole seafood industry in Ireland. Okay, so just looking then at the blue economy. So the blue economy provides us with food, water, jobs, and it's a source of economic growth. And we know that key to the blue economy is a sustainable and equitable growth of all interests. Now, I work in the Development and Innovation Unit of BIM. It's one of 6 units, and our projects and our work are all underpinned by sustainability, because sustainability is one of the strategic pillars for the organisation. Just to quickly talk to you about 2 of our current projects that we're working on in our division, the Aquatech project and the Aquaculture Innovation Workshops. Okay, so starting off with the Aquatech project. The first project I'm going to talk to you about. Okay, this project is about the development of a cost-effective automated farm management system for the aquaculture sector. Initially, it's going to be built for the oyster sector, but then it'll be planned to be rolled out to the other sectors, mussels, salmon, etc. Right? Now, this project is being headed by IMAR, who are based in the Institute of Technology Tralee, which is a college in the southwest of Ireland. IMAR is a knowledge gateway technology gateway, and they work and partner up with industry on projects such as automation and manufacturing services. Another partner in the project is Fexico. They are a multinational and in the financial and business solutions area. And then ourselves, BIM, we provided the funding for the project. So this project, okay, the farm management system will allow process monitoring, alerts, yields, monitoring of shellfish on the farm, and full traceability. So remember, it's been developed initially for oysters, so this is where the current work is at. The project will develop the software and the hardware to carry out all of this. So the process monitoring, the alerts, the yield monitoring of the shellfish on the farm, and the traceability. So if I was to give an example, this system, and if I'm going to use it as an oyster farmer, I will be able to sit down and open up on my device or laptop this product. We'll call it the Aquatech product. When I open it up, I will on my screen be able to see a layout of my farm, my oyster farm, and where everything is on my farm. I, as the farmer, will then be able to say, I want to set a task of work I want done today. So I want lines 1 to 5 in block A on my farm. I want all the oyster bags turned today. So he sets that as a task. There is a worker on the shore, could be 10 miles away in another country. He opens up his device and he sees his tasks or his jobs for the day. So he sees, oh, the owner, he wants rows 1 to 5 in block A, all those bags turned today. So the worker goes off, does his work for the day on the tide. And then when he's finished, he can actually log the task has been complete. So the system updates. The system will allow the farmer to grill it or to query it. So as a farmer, I will be able to query and say, what have I got on my farm as grade 2 oysters? So he will know he has 18 tons of grade 2. He has 40 tons of grade 1. All this information will be able to allow the farmer to make better business decisions, better planning for sales, and increased efficiencies, of course. Full traceability will be built into the system. So throughout the production process, from the seed coming onto the farm, through the production process, to the oysters being sold off the farm, the system will record full traceability. And it's also planned that the system will be capable of environmental monitoring. Now, this will be done via feedback of data from a series of water quality sensors that will be deployed on the farms. So just a quick snapshot of what it's an exciting project that we're really interested in. That's happening, that we have funded. And moving on to another project that we are involved in. This BIM innovation workshop, aquaculture innovation workshop. This is a 2-week program and it's managed by Hatch, which is a global accelerator. Now, this 2-week aquaculture workshop, the aim of the program is to identify and cultivate concepts and to basically build a pipeline of indigenous, scalable, commercial, viable aquaculture companies. This is the 2nd year that we've run these innovation workshops. There is usually about 10 places on the workshops, and they offer, you get access to investors, experts, mentors, specialists, all tailored to the aquaculture sector. So it's a really focused workshop. And, we as an organization recognize that key to any vibrant industry, you have to have a constant stream of new ideas and innovations to keep the industry vibrant. In this picture here, these are some of the cohort actually from last year's workshop. So just to give you a feel for some of the participants, this was Martin from Univiv. Martin was looking at the marketing and manufacturing of products for animal and human health. Stephen from Catch a Trade, he was building a super app for seafood traders. This is India. She was from the actual Hatch, the accelerator that we're actually managing it for the workshop on our behalf. This is Jim O'Toole, our CEO, looking very happy with all the participants and all the lovely new companies coming out of that workshop. This is Elena from Seafresh Group. Kate, she also took part in the workshop. She had 2 companies, one looking at aqua licensing and issues around that and dealing with those issues, and then her other company, the Irish Seed Mussel Company. Actually, and this was John here on the right hand side. John and his company Impact 9 was looking at the whole offshore anchoring and developing new pen systems for aquaculture. So it just gives the participants are just so broad in spectrum, but they're all in the whole aquaculture sphere of things. In fact, I actually thought I would be coming live from this year's workshop because it's currently in the 2nd week of our 2nd workshop. We were supposed to be running it here in the southwest of Ireland in Kerry, in a beautiful location. Unfortunately, due to the current situation with COVID, we had to move the workshop online. So this here is Wayne. He's the CEO of Hatch, who are running the workshop on our behalf. They have used the platform Remo to deliver the two-week workshop. This is just a view of it in presentation mode, where Wayne is given a presentation on the first day of the workshop. So we have an area for chat, participants, questions, and this is the presentation mode where the person who is giving a talk or a presentation. This here is in our networking mode. So they decided to develop an island. So if you're taking part in this workshop, you're going to feel lovely and nice and as if you're off somewhere exotic. So this is where, you know, we have coffee bars, so you can hang around and chat and meet. We have an actual bar. There is tables here where you can arrange meetings with one-to-one sessions with mentors and speakers. There are other areas up here for more people can gather to have chats. We have here, this is the BIM boat. So if the participants, after a presentation and people have a coffee break, somebody might say, oh, I'd like to go over and chat to BIM. I have a question about something, you know, that they might be able to help me about. So there's myself on the BIM boat, and some people have come to visit me during one of the coffee breaks and have a chat. So this was on the BIM boat. So there's myself and Damien, my colleague from BIM, and two of the cohorts from this year's program had come on for a chat onto the boat. This is Rory, and he has a company that is looking at alternative methods for treating of sea lice. And Brian, he has a company and he is looking in the whole area of fish health diagnostics. So the workshop is going excellent at the moment. We've got really good uptake and participation and engagement from all the participants. So that's our workshop, and it's ongoing online as we speak. And then I just thought I would like to introduce one of the many female entrepreneurs that we have here in the Irish aquaculture sector. Ciara is the managing director of Red Bank Food Company. She grew up around her father's seafood export business. She studied outdoor education and she went on to work with youth and community development in Kenya and Ireland and Zambia. And she came home. She said it was always the sea was calling her back. She came back home and she set up the Red Bank Food Company in 2015. In 2016, she then branded the Flaggy Shore oysters. This is where she works with local oyster farmers to bring their product to the market, essentially. Since branding the oysters, she's done everything from music festivals, farmers markets, weddings, you name it. She says anywhere that she can go and put an oyster in front of somebody to try it, she'll be there. She's also actually supplying some of the top Michelin star restaurants in Ireland, as well as local casual dining establishments. This actually, sorry, that last slide was where her company is located. It's located on the west coast of Ireland in County Clare, in a lovely part of the country. Something that Ciara has started to do in the last 2 years is she started to look at working in the area of tours and niche experiences. She basically bringing people in. It's mainly through Airbnb. She teaches them about the biology of oysters, how they're farmed, the local marine life, and how to shuck oysters. As you can see here, look, Ciara has basically put tables in her oyster dispatch center. So people come, they see the oysters in the tanks, they learn about them, they learn how to open them, and then they sit down and they enjoy them. And I've heard it's a great tour. Also, Ciara was awarded a Nutfield scholarship. It was the first scholarship that BIM sponsored in the marine and aquaculture sector. Her area, her topic was in the area of food tourism and how it could be used as an educational tool, as well as generating income in rural areas. Now, Nutfield basically is a network of about 1,500 scholars globally, and they are from all various aspects of the agriculture sector. And they're committed to learning best practice and promoting leadership within the industry. As part of the scholarship, Kira got to travel to 9 countries. She met with producers, researchers, government departments, ministers, and fellow producers. And she just thought it was an extremely worthwhile and great experience. And she said she learned and brought so much home, which she hopes to, bring into her business. So I just thought that thank you for a very whirlwind introduction to aquaculture in Ireland. I hope it was of some interest and that you learned something today.
Thank you very much, Catherine, for being with us and for this introduction to aquaculture in Ireland. I think it's very exciting to see how entrepreneurship is fostered and how rich is the economy based on aquaculture. Thank you very much. I don't know if there are questions now. You can always type in the chat, and we can go afterwards even through the questions if you like. I'm going to present now the NANOCULTURE project. Okay, I hope that you can see my presentation. Well, I'm okay. So today we were expecting to have initially an introduction by Julie McGuire from Indigo Rock Marine Research Station. That is one of the partners of NANOCULTURE project, but unfortunately they are having some connection problems. Well, it's 2020 and 13th, so maybe the date is not helping. But I will make the introduction, and unfortunately enough, Julie will be able to join later on. So NANOCULTURE project, as I commented in the beginning, is a project that was founded by Interreg Atlantic ADIA program, and is devoted to the risk assessment and mitigation of the presence of engineered nanomaterials in Atlantic aquaculture. So I will try to explain why it is interesting to study this and our initial results in the project. This project started in May last year. Unfortunately, we had a kind of a gap during this year because of the COVID situation. But we have, we think, some promising results, and we would like to share with you. Okay, first of all, why studying engineered nanoparticles and their impact in aquaculture? Engineered nanoparticles have been over the place in many industrial products since some decades now. And they provide very specific properties that are very interesting. Most part of them are based on their size and the high surface area that they have exposed to the rest of the media. And for you to have an indication on those ones of you that are not working in nanomaterials or nanotechnology, this could be the comparison in the scale of size. So we will have the Earth, the Homo sapiens coronavirus every day present here. And engineered nanoparticles will be in the range of 10 to -9 meters. So these engineered nanomaterials, as I told before, they are present in many products, consumer products, because of these special characteristics. Depending on the type of nanomaterial, they will be used in different type of applications. But this is more or less an idea of which is the production volume that we can find nowadays. This is even not nowadays, but this is 2015 production volumes worldwide of engineered nanomaterials. And among the ones that are represented here, you can see here that titanium dioxide and silver nanoparticles are among the most produced ones, with worldwide production over 10 to 4 tons per year. Well, these nanomaterials can be used in many different applications. As you can see here, many of them are used as coatings, as catalysts, as composites that are increasing or improving the properties of several materials. You've been hearing a lot, I think, about some of these nanomaterials, such as graphene or carbon nanotubes. The ones that we are focusing in this project are silver and titanium dioxide nanoparticles. And as you can see here, these type of materials are very much used in personal care products, coatings in medical devices, as using them as antibacterial materials, and they are providing very interesting characteristics to these products. As a typical example, titanium dioxide is one of the materials mostly used in sunscreens. So taking into account the production volumes and the specific characteristics of these nanomaterials, it's obvious that some of them will reach the environment, and aquatic environment and marine waters is one of them. They will reach through degradation of the devices or textiles, where nanoparticles can be some effluents from wastewater treatment plants can contain this kind of nanoparticles. And then there is always the possibility of them reaching aquaculture facilities in open sea mostly. So we were wondering if there was really a risk because of the ingestion and absorption of engineered nanoparticles, because in aquaculture products, these are commercial products that will reach the food chain, and then we will consume these products. So our interest was to try to figure out if there was a risk behind this. And one of the reasons for this is, for instance, titanium dioxide nanoparticles have been used since some time ago as a food additive, and nowadays there is concern about the use of food additives, and in particular titanium dioxide. In fact, in France it was banned very recently. So nanoculture, as we told before, is going to deal with the risk assessment of the presence of these nanomaterials in aquaculture products. The main objectives for this project is the study of the accumulation and effects of nanomaterials in aquaculture products. On the other hand, evaluation of human exposure risk because of consumption of potentially contaminated seafood or fish from aquaculture, and the development of in situ sensors to be used in the aquaculture facilities in order to detect and identify the presence of these nanomaterials. Well, the partners in this project are Indigo Rock Marine Research Station from Ireland, Universidad de Vigo, Universidad de Santiago de Compostela, and the cluster of aquaculture in Galicia, in Spain, INL and CMR from north of Portugal. INL is leading this proposal. Then we have Aquimer as an associated partner, and that is a pole of a cluster of aquaculture producers in France. The total budget for this project is 1,470,000 euros, and with 75% of funds by the European Union. And the main work packages are here. We have some of transversal for coordination, communication, and capitalization of the results. And then the more technical ones where we study accumulation and effects of the nanoparticles. We evaluate the human exposure risk, and we develop the sensors for the nanomaterials. So now we are going to present the project advances so far. First of all, we had to decide on the target species. So we wanted to study different types of aquaculture species, but with high commercial value. We selected turbot, marine mussel, and some incipient species of seaweed that are being used more and more for aquaculture. Palmaria palmata and Ulva fenestrata. So this species, the exposure will be done or was done with silver nanoparticles and titanium dioxide nanoparticles that are commercial. So we are not dealing, as you can see here in transmission electron microscopy images, the size distribution and the aggregation state is not ideal, but we are dealing with commercial nanomaterials, so it's not the same as working with perfectly characterized and done nanomaterials from the lab. So these are nanomaterials that are commercial and that are being incorporated in commercial products. So first, in order to study the risk of bioaccumulation of these nanoparticles by the different species selected, we artificially expose these organisms to some environmentally relevant concentrations of the nanomaterials. And we do that in tanks for mussel, for turbot, and for the seaweed. The exposure for mussels and turbot are always through feeding. So for mussels, we will expose mussels to nanoparticle contaminated microalgae. Microalgae are the food for the mussels. So we wanted to know how the mussels will accumulate nanoparticles that are associated or not with microalgae. And the exposure will be during 28 days. For turbot, the exposure is through pellets that constitute their food, and the nanomaterials are included in the pellets. And the exposure is during 90 days, sorry. For the seaweed, the exposure is directly through the water, and 28 days as well. Well, first thing to comment is that in the exposures performed with turbot, we observed that there were not during the experiments there were not significant differences in the weight gain. During the exposure, the turbot were fed with these pellets containing the nanomaterials or not, as in the control, and they were gaining weight as usual. It's true that with titanium dioxide nanoparticles, initially they didn't gain the weight that they should in the first times, but this was mainly due to the different acceptance of the turbot for the food, because the taste is not the same, but then they recover the appetite for the food and gain the weight as usual. For silver nanoparticles, we didn't notice even this. So we can tell that there were no mortalities, no significant different behavior, and no significant differences in weight gain during the experiments. Well, then we started to study the bioaccumulation, and we do it in different ways for quantification of the nanomaterials or the nanoparticles that are in the bodies of these aquaculture species. We had to perform first the extraction of the nanomaterials from the flesh of the turbot and the mussels and the seaweed. And as we want to know not the total content in metal, but the nanoparticle, the content in nanoparticle, we need to perform methods that will not destroy the nanoparticles in the process. And in order to do that, we need to perform soft digestion of the samples. And that's why we use mainly enzymatic digestions. Then we filtrate and we analyze using single particle inductively coupled plasma mass spectrometry. This complicated name of technique allow us to quantify nanoparticles by flowing the sample in the detector, and we will obtain peaks. These peaks correspond to the nanoparticles that are appearing over the detector, and the intensity of the peaks will correspond to the size of the particle. Well, for the nanoparticles that we are using, you can see that this will be the spectrum of the size range that we will obtain with the nanoparticles. For the titanium dioxide nanoparticles of around 50 nanometers, we will obtain most part of the distribution of the size here, around 50, 60. And for the silver nanoparticles of around 20 nanometers, we will see here that the frequency of the sizes are mainly between 15 and 30. And when expose the mussels to these nanoparticles artificially, what we can see first is that we can recover well the sizes of the nanoparticles that were spiked. This is not result from the bioaccumulation, but the setup of the technology for the use of the digestion and the recovery of the nanomaterials. We are now working on the analysis of the bioaccumulation studies. Another way of studying what's happening in the aquaculture species with the nanomaterials, it's to study the distribution through the tissues, and to study if there are some histological effects of the nanomaterials exposure. So you can see here some examples of tissues. This is gills of unexposed mussels. This is gills from exposed mussels to titanium dioxide nanoparticles, and this is mantle of the mussel. What we observe is that first of all, when we analyze with transmission electron microscopy these samples, what we are seeing is a teeny tiny portion of the tissue. So only if we will have a big accumulation of nanomaterials, we will be able to find nanomaterials in the tissue. This was not the case so far, but what we could observe, this is what we could observe, is a general disorganization of the tissue in the gills of mussels. And this is helpful for us to try to understand what are the effects of the nanoparticles, if there are some, in the organisms themselves. Then for turbot, so far we analyze muscle, we analyze kidney and liver, and intestine. Here you can see several transmission electron images of tissues not exposed. This is muscle, this is intestine, and you can see here kidney that were exposed to titanium dioxide nanoparticles. And we cannot see nanoparticles, so there is big significant accumulation that we can report by electron microscopy. But what we can see is that there are some effects, such as this enlargement of the endoplasmatic reticulum. So we think that there are some effects in some of the tissues of the turbot. Well, next step is to study which are the molecular effects in the physiology of the organisms, and this is studied by CIMAR. What we are doing is to study proteomics and transcriptomics. So we are studying the proteins that are being altered or not by the exposition to nanomaterials, and the expression of the genes if this is changed in the exposed nanomaterials. So far, some glimpse of what we could find is that after 14 days of exposure to silver nanoparticles in turbot, there were, well, in the analysis, 1,572 proteins were identified, and a significant portion of them were affected in the sense of different from the control fish. And some of the things that we can tell nowadays, this is our preliminary results, is that some of the proteins that were altered are related with immune system and detoxification. So these alterations could be even a positive reaction, let's say, to detoxify the fish. It doesn't mean necessarily that there is a toxicity effect behind this. Then for muscle, there were a big bunch of proteins that were analyzed as well, 2,353, and 101 were found different from the controls. And some of the things that we can extract from here, for instance, is that silver nanoparticles exposure cause overexpression of some of the proteins, including this protein and TCTP, that are involved in the regulation of cellular metabolisms and organ homeostasis. So this could be indicating that the muscles are reacting to the presence of these nanomaterials in order to activate the detoxification processes. Well, the next step is to study which will be the behavior of the contaminated species, aquaculture species, in the ingestion by the humans, and if they will get absorbed or transformed in the digestive tract. So for that, we use in vitro models for human digestion studies. First, we study in vitro bioaccessibility of the nanomaterials included in the aquaculture products. So what we do is to mimic the conditions in the gastrointestinal tract by changes of pH and exposure to different conditions that imitate what happens in the digestive tract. And then we use this extract to an in vitro bioavailability study that is based on CACO2 cells that are intestinal barrier cells that we can grow in transwells and then expose to what we are expecting to get in the lumen of the intestine. And like that, we will assess if there is transport, if there is effective transport of the nanomaterials that arrive to this intestine to the rest of the organism. And this we will see by evaluating the nanomaterials that are passing through this monolayer of cells. Well, Last, it's our developments in the in situ sensors for rapid detection of the nanomaterials. So we wanted to generate as well tools in order to track the presence of these nanomaterials in the field. The idea is to end having decentralized monitoring systems, as Catherine was commenting, with other water quality parameters. We think that we can provide tools to check the presence of the nanomaterials in aquaculture waters. So we are developing a prototype that is based on a pre-concentration module, because the concentrations that we are going to get in the water are going to be really small. And in order to increase sensitivity, we need this pre-concentration. And then we will have a sensing module. We are exploring different mechanisms of the development of the sensors. For titanium dioxide nanoparticles, we are exploiting one of their properties, that is the fact that titanium dioxide nanoparticles are able to break organic compounds in the presence of UV light. So we are using this property in order to track the presence of the titanium dioxide nanoparticles in the water. What we are doing is to use supports in order to have filters for concentrating the nanoparticles that are present in the water. And then we expose these filters with the titanium dioxide nanoparticles trapped to a dye. This dye, in the presence of UV radiation, will get destroyed or degraded on the concentration of titanium dioxide nanoparticles that we will get. And as you can see here in the first, in the initial assays, we got a sensitivity around 10 ppms. In order to increase sensitivity, because as I was commenting, the concentration in the water is going to be very low, we are exploring other options, such as the fact that we can enhance the activity of the titanium dioxide by using gold nanostars that are plasmonic particles that could be illuminated with a source of infrared light. And when close to the titanium dioxide, this will result on the degradation of this dye with infrared light, and not necessarily with UV light. Then what we are doing is to grow this or to attach these gold nanostars in the surface of these fibers of titanate, and then we perform the same assay. And as you can see here, as a summary, we can, at certain conditions of concentration of gold and titanium dioxide, we are able to detect lower concentrations of titanium dioxide, and we are working on improving the sensitivity. Well, and then for silver nanoparticles, we are exploring another type of sensing method that is based on Raman spectroscopy. And the signal from the molecules can be enhanced heavily by using plasmonic particles such as gold nanostars. What we are doing is to follow a reporter molecule that has high affinity by silver nanoparticles, and it's attached to the gold nanostars. So when we have in the media silver nanoparticles, they will get attracted by this molecule, and this molecule has a signature in Raman. This will be enhanced by the presence of the plasmonic particles, and further enhanced by the presence of silver nanoparticles that are plasmonic as well. What you can see here, and this is the spectra that we will get, and the increased intensity of the spectra when we have silver nanoparticles. What you can see here is that effectively we could check in electron microscopy the interaction between the gold nanostars and the silver nanoparticles. So we are checking this method with different types of silver nanoparticles, because we will find in the media different types and different sizes. And as you can see here, for the bigger ones, the method can work well. For the smaller ones, we don't have a good fitting so far, so we are working on this, because silver nanoparticles will be present even in this size. And one way of improving the sensitivity of the method, and as well the reproducibility, is to support the gold nanostars, the substrates for this method, in several supports, several materials. In this case, we are supporting in acrylic. We are sorry, checking in glass wood as well. And these supports are being incorporated in cartridges where we can flow the liquid and perform in situ the detection, and can be reused. So this is what we are doing now to improve the sensitivity and the reusability of the detection methods. So this is a summary of what we've been doing so far in this project. We expect to have your contributions as stakeholders. So we encourage you to participate by subscribing on our website, by joining our workshops and webinars, and if you are interested, by sending us aquaculture products to test, or even to provide a space in your aquaculture facility for checking the presence of the nanomaterials. And we encourage you to subscribe and to follow us in these channels. I would like to remind you that there is another session in Spanish on the 16th. So if you want to attend this one, more or less the contents regarding the project are going to be the same, but you will have other speakers there. And thank you very much for joining us today. If there are questions, I can reply now.
There are a couple of questions. Maybe Begoña, you can see in the question and answer section, in the answer ones, you can see there these questions from Yuns Boalegi. Sorry,
Okay.
maybe I'm not pronouncing well the name.
Okay, taking into account the already identified proteins, just to want to know if you have done some tests on the immune cells of muscles, or histopathological assessment on the gills and digestive gland, to figure out if there is any particular stain modifications on the structures and or morphological features on the cells. Well, I must say that the results that we obtain in transcriptomics and proteomics are very incipient, are very recent. So far we didn't dig in so much in the mechanism of action. We saw by electron microscopy for sure that there are some disrupting effects in the gills, but we cannot associate for sure for now which is the reason for this disruption. I don't know if I answered properly, but we hope to have more data soon. Otherwise, in virtue of the TCCA proteins identified, is there any possibility to develop any neoplastic figures either by hemocytes or epithelial cells? Well, Mario, would you like to comment?
I can comment both to Yuns Boalegi. Sorry, the pronunciation. So really the protein tests are in an early stage of analysis. We just received the initial results last week, so we didn't have much time to check all the changes on proteins profiles. And as Begoña said, there is lots of proteins that still need to be analyzed, and all the functioning might have a positive or negative expression, and we still need to look up for all the proteins that were significantly affected by the presence of nanoparticles. So, but it's a very interesting question, and of course, the analysis of results between transcriptomics and proteomics with the histopathological changes is very relevant, and it will be an interesting thing to be complemented. But thanks for the question, and but at the moment we can't have further results. But during the project, of course, we'll try to do new research and to make new papers on this issue, because it's very relevant and there is not lots of information. And I think that's it. Thanks.
There is Mario. Don't go, because I think that question from Iria is as well suited for you. She's asking if the effect of silver nanoparticles generate an overexpression of pro or anti-inflammatory molecules in turbot.
I think silver nanoparticles were the ones that were shown. For the titanium, we are still analyzing them, and it's the same. At the moment, we still have like not so many in-depth analyses, so it's difficult to say that it will have a pro or anti-inflammatory. For some proteins, it looks like a positive, or I would say it's an antimicrobial activity induced, but it's too early, because we need to see like all the big picture, not only the small responses. So I would say that a few more weeks and we might have relevant and interesting results.
Okay, thank you. I think I'm not seeing any other question.
There is a comment from Alexandre. Just 1 second.
Okay.
He says, thank you very much for the webinar about the NANOCULTURE project. I have a question more concerned with the current situation of nanoparticles in the environment. Is there legislation about the levels of nanoparticles in environment and aquaculture or food production systems? If not, can we expect legislation in the near future?
Okay. Regarding aquaculture, there is nothing that I can tell now. There is no legislation regarding nanomaterials. This is not even recognized as a concern, and in fact, this project is one of the first ones that is exploring if this could be a concern. What I can tell is that the concentrations that were found in marine water so far of these nanomaterials are not so high, but this will depend a lot on the location as well. For instance, close to beaches, you will find sometimes high concentrations of titanium dioxide nanoparticles that come from the leaching of the sunscreens. But in principle, the concentrations that we will find will be in ppbs or below that. So it's not clear that this is a concern. We are trying to investigate and prevent that this is a concern. In food, there are other types of legislation, and titanium dioxide nanoparticles are accepted as one of the additives. It has different uses, but it started to be a concern for several countries in the European Union, and France was the one banishing the use of titanium dioxide nanoparticles in food. We could expect other countries to join this legislation, mainly in the European Union. We don't know for sure what is going to happen now. what we are trying to do is to give more information about this, and this is expected to help to understand if there is a need of regulation afterwards. I don't know if I answer.
Then there is another comment from Yuns, and he says that he just want to highlight that it may be important to consider this matter. I guess that the matter that we were discussing before with him, just because many reported that tumors in muscles are contagious and may cause really huge problems and big mortalities once it has been occurred with formed populations. Literature by Antonio Villalba, The Sick Spain, could be considered in this virtue.
Mm-hmm.
Yeah, it's an interesting comment. We'll keep an eye on that issue for sure. Thanks for the comment, yes. But Ewan, I should say that he asked to make a presentation during the webinar. We are really sorry, but the time expected for the webinar this time was very short, so we didn't have time for external presentation. But who knows? Next editions we might rethink about the format and consider the external presentations. But of course we can keep contact regarding this matter, because as far as I understood, Johannes is also a researcher, and he is studying the effects of I think it's silver nanoparticles on Mytilus galoprovincialis. So it makes all sense to keep an eye on his work and keep working together for understanding what's happening with nanoparticles on Mytilus galoprovincialis. So thank you very much again for the interest.
Okay, I think there are no more questions at the moment.
Well, then it's only to thank you again for your presence and your participation. We hope to see you, many of you, if not all of you, in next meetings where we expect to give you more insights on the research that is being carried out in nanoculture.
Thank you.
Thank you very much.
Bye-bye.
Thank you.
Thanks. Bye.